In problem 4, we're given that f of x is even, and then we're told some information about a definite integral involving f of x. And very suspiciously, we have from -6 to 6. So the reason that we have this particular setup from -6 to 6 is that we're given that f of x is even. When f of x is even, that means, see, graphically, f of x has symmetry about the y-axis. The graph of f of x is symmetric about the y-axis. And what that means graphically, y-axis, what that means graphically is that if we have a mirror image, the right is a mirror image of the left. What that means in terms of definite integrals is that the integral from minus a to a of f of x dx is just twice the integral from 0 to a of f of x dx, because the negative side looks the same as the positive side. So if I just take 2 copies of the integral from 0 to a, that will give me the integral from -a to a. Our favorite example of this cosine x. Cosine x as well, it's my favorite example of this. So if we integrate this even function from 0 to pi, oops, I didn't want to do all that. I wanted to integrate from 0 to pi over 2, sorry. It actually doesn't change my point. Now I'm thinking about it too much. Oh, good, I'm glad I'm recording all this fumbling about. Always good to have. So if we integrate from 0 to pi over 2, integrating from 0 to pi over 2 gives us an area of 1. And since the left side is just a mirror image of the right side, the area from negative pi over 2 to 0 is also going to be 1. So if we integrate from negative pi over 2 to 0, we also get an area of 1. So that's what we're going to employ in this particular problem. We have the integral from -6 to 6 of f of x minus 8 is equal to 2. So let's just start breaking that apart. Integral from -6 to 6 of f of x minus 8 dx. Now, we're subtracting 8 from the f of x, and the integral that we're looking for is from 0 to 6 of just the f of x, not f of x minus 8. So what we can do is isolate the integral from -6 to 6 of f of x. We could use properties of integrals to split this apart. So we get the integral from -6 to 6 of f of x dx minus the integral from -6 to 6 of 8 dx. That's properties of integrals. The integral of a sum is the sum of the integrals. The integral from -6 to 6 of 8 dx, we can just multiply 8 by the distance from 6 to -6. So the distance from 6 to -6 is 12, and 12 times 8 is lots. What's 12 times 8? 108? 96? Something?
96. 96.
Arithmetic isn't my strong suit. So this is all 96. And we know that this is equal to 2. We were given that this is equal to 2. So that tells us that the integral from -6 to 6 of f of x dx is 98. And this will be twice the integral from 0 to 6. The 96 came from the integral from -6 to 6 of 8 dx. From -6, whoa. Too much coffee or not enough? From -6 to 6 is a width of 12, and then the height of the function is 8 everywhere. And so 12 times 8 is the 96. 80/16, I don't know why I not stopped doing math the way I normally do. So this tells us that the integral from 0 to 6 of f of x dx is half the 98, or 49. Questions? We're still not sure about this 8 times 12 being 96, not that part, but the reason that -6 to 6, the integral, -6 to 6 of 8 is 96. We can actually evaluate the function, because what it'll look like is 8x evaluated from -6 to 6. So that'll be 8 times 6 minus a -8, an 8 times -6. So it still works out if we find the integral. So this integral here would be 8x evaluated from -6 to 6. So that'll be 8 times 6 minus 8 times -6, which is just 8 times 12. The original question was to find the integral from 0 to 6 of f of x dx. So our task was to just use properties of integrals to break apart the one that we were given.
So it's basically we find the 98 and just divide it by 2 to get what it is.
Yes. And that's using the fact that f of x is even. Any questions? All right, let's pause the video here and talk about what should go on in the coming weeks.